So welcome back after I don't know how many days. Okay, so today's question is minimum cost walk in the weighted graph. And I wanted to make a video on this question because this is such a beautiful question. So easy yet so difficult. Uh, I just have an idea of how we might be able to solve it. I haven't solved it before, so it's on the life. So it might be that the solution that I'm thinking is wrong and it's just hard, not at all easy. So we don't know. Let's see. So if the question is that we have a graph here and we have edges and each edge has like from to and a weight, and then we have a query array where we have to tell from in each query we have to tell we have to go from source to destination, and we can revisit any vertex any number of times, and the thing that we have to minimize is the and bitwise and of all the edges, edge cost, whatever it is. So one beautiful thing about and is it's not beautiful, the definition is that even if there is at least one zero in the whole thing, everything becomes zero. No matter how much progress you've made, just one zero if you've encountered, it's all zeros. So this like brings us to the point that if we have a connected component of 4 vertices, it is always best, no matter from where you're starting and where you're going, it is always best to traverse the whole vertex, the whole array, the whole graph. And we can do that because we can revisit any vertex, any edge as many number of times as we want. So that means there is a possibility that we go and collaborate with the cost of each and every edge. And why we are doing this? Because why not? If it's a 1, it doesn't change anything. If it's a 0, it becomes 0. So it's always best to try every value possible. So that is what we are trying to do. So there are 2 cases. So from the source and destination, for each query, if the source and destination, if both of them are in the same component, the same connected component, if they are connected, then the value, the lowest AND that we can get would be the AND of all the values, all the costs in that connected component. And if the source and destination are not in the same connected component, then that means we can't do that. So then it boils down to the answer would always be, if it's a connected component, the bitwise AND of all the costs in that connected component, and if it's not a connected component, it would be -1. So this is what I was thinking, that this might be the answer. I can't think of any cases in which it might be wrong. So one way to find out the mighty submit. So yeah, and to find if the source and destination are in a connected component, I'm using union find. You can use other things also. You can use BFS. You can go from source to destination, see if it's possible or not. But I'm going with the union find because it's easier to write and it's fun to tell, fun to explain. Okay, so we have the parent array dictionary. Then I have defined if x is not in parent, in that case parent of x equals to x, else parent of x is equals to find of parent of x, then parent of x. Wait, is this correct? It's been so long, guys, since I've solved problems on LeetCode. It's been like 5 to 6 months. I forgot how to implement uh, union find, so please bear with me if I'm taking my time. Parents of x equals to we find the parent of x and then put it back. Yeah, I think this should be right. And then def union if find of x take x equal to find of x. I'm finding the leader of the x cult and the leader of the y cult. If both are same, do nothing. Else here I'm not doing currently I'm doing path compression here, but I'm not doing what is it called, join by size, union by size, I think, because first I want to just see if the solution is working, and if it's working we can do other optimizations later. So I'm just putting parent of x equals to a, and now for source dest cost in edges. Okay, so wait, okay, I'm thinking using union find I would be able to find if the source and destination are there in a, if the source and destination are in the same component, but how would I find all the costs related to that? For that I can maybe use a bitwise bit and use one more. Should I use, yeah, okay, I'll use one more array where I'll store bitwise and of each component. But how would I retaliate, how would I like collaborate if I'm joining A and B, then the bitwise and of A should be bitwise and of A and B, and the bitwise and of B should be bitwise of B and of A, B and B, B and D. We can do something like that. So initially it would just be the same number itself. Bitwise of one number is the number itself, and when we are joining, then bitwise and of x is equals to bitwise and of y is equals to, wait, so if 0 and 1, okay, one good thing about bitwise and is we can and as many times as we want, and the answer will still be the same. Like if I and A with B and then with B, 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 it will still be the same. So I should not be worried about duplicates. But I'm thinking here x and y are already resolved. How would I do bitwise and? If I do parent, how do I store this bitwise and of each component? If A and B are in a component, I have to find all the elements, all the okay. How do I find, bro? So if we have 7 and 1, okay, if I put 0 and 1 in the same component, I'll add that. Okay, so here's the parent would be y is equals to and is equals to bitwise and of x. It's just like the size, but instead of adding the size we add the bitwise and of the smaller component, I mean the smaller component into the bigger component. Would it work? I don't know. Let's check. Bitwise and of y is equals to bitwise and of x. Okay, let's do this. Union of source, comma, destination. This bitwise and of x. This cost is not correct. Okay, I have to pass this also, maybe. Bit and of 0. Okay, if you and with 1, it doesn't matter any. It doesn't matter, right? I think you should always pass. Bit. Wait, bit is and. Okay. Okay. So, okay, no, I have to pass this cost also. And I have to take this cost, pass it to find as well. But if I do that, okay, now I have two components and a cost, so that means both are going to be 1, and I have to this is little bit confusing, guys. Stay with me. My brain cells are almost dead. It's 4 o'clock in the morning. I'm making the y parent, then bit and y is equals to whatever the cost the had, and then cost of this. Okay, but this can't be true then. What is bit and of x is not there. It's not present. I think initially all bit because bit and with 1 it doesn't do anything, right? So how big is the element is as big as, bro, weight is as big as 10 power 5. How many bits is 10 power 5? How many bits is 10 power 5? Okay, it's just 17 bits. I'll take 18 bits. Okay, This is like 18 ones, that's it. I'm doing this because I'm stupid. I don't know what to do with bitwise and like default. Okay, union of this I'm doing cost, and then answer. I have to return answer only, no? For source comma dest in query, sorry. Bro, you have so many queries. Why would it be a query? It will be queries. Stupid. Okay. And now I have to check if find of source is not equal to find of dest, then they're not in the same component. Then answer would be -1. Else answer would be bit and of find of source. If both are in the same component, then find of source and find of dest should be same, so 1 is enough. I don't know, bro. I have a very bad feeling about this code. What? Fix is not in correct only, no? If x, okay, I think if x not in, sorry, what is x? See, this is what happens when you try to write English in Python. Here, okay, here if parent of x is equals to fix, if parent of x is equals to x, then we have to return because it is the leader. No, it doesn't have a leader. It's like Pushpa, no boss, he is the boss. Whoa, this printing. Let me just submit. Okay, it is wrong. Let me see why. See, I knew that it's a hard question. The answer wouldn't be that simple. Okay. Okay, everything is 0, they're saying. So it's, I think it's all a connected component. 2 is connected to 3, 3 is connected to 1, 1 is connected to 2, 3 is connected to 0, 1 is connected to 3, 0 is connected to 2, 1 is connected to 1. It's big Alabama family. Everything is connected to everyone. So the and should be 1 and 5 and 6 and 7 and 7 and 5 and 7. 1 and 5 and 6 and 7 and 7 and 5 and 7. Bro, twice and huh? Bro, there is 0 here. Are you stupid? ChatGPT is stupid. So so every column has a 0. So that means it is going to be 0. And my code said it is 4. So first I want to check if everyone has the same parent. Because if it is correct, everyone should have the same parent. 2's parent is 0, 3's parent is 0, 1's parent is 0, 0's parent is 0. Okay, everyone's parent is 0. Now I want to print bitwise. So our union find is correct, but the way we are storing this bitwise and propagating this bitwise and is wrong for some reason. 2's bitwise end is this. 3's bitwise end is 4. 0's bitwise end is 4. Okay. Why is it so? Or I can do one thing. For every element, for every vertex, we can take all the edges that it has and add it to the bitwise AND to that element. That makes sense, no? That makes sense, because if it is connected to one vertex, that means if it comes to one, it can go to all the edges that is connected to. So that is one thing we can do. This doesn't look very convincing, but this, it wouldn't be very, I don't know what it. I'm just removing bitwise AND from here, and while getting this only, I'll add I'll remove cost. So once after that, we'll have bitwise AND of every element. After that, I have to check. Once I find both of them are in the same component, I have to go to the component and do bitwise AND of all the elements in that component. That will be too slow of an worst case. Not good. I think our old plan is only better. We have to little bit improvise. Let me think of. Okay, so we have x and y. Let's assume bitwise AND of x would contain okay, let's start with two elements. So if A and B become a pair, the leader A would have AND of A and B. Now if C joins B, then A's AND and B's AND are joined, and this new links cost is added to the path. So it should be something like this only, right? So bit AND of y is equals to bit AND okay, this is mistake. Like we have to consider bit of its bit also, no? Yeah. Okay, now it is passing. Let's pray that all the test cases pass and we can sleep. Woohoo! Yeah. So guys, welcome back. I'm back to LeetCode. See you tomorrow.